Cool. All right. Hello, everyone. Welcome to the data facing call for July. If this is your first time here, we are a part of the Campus Research Computing Consortium, or CARC, which has kind of two ways to be involved. There's the People Network, which is year-round virtual conferences. We have 4 different tracks. And then there's also the Working and Interest Groups, which are groups that form around a specific topic, and they often create deliverables such as the capabilities model for research computing and data. And so if you want to get more involved in any of these, there are 3 links here on the slide with more information about what these groups are and how you can join. Reminder, we also have a detailed code of conduct, which is linked in the call doc if you are interested in looking at that in more detail. So one new announcement is we're interested in starting up a steering committee for the data facing track, very similar to how researcher and systems facing have. So this would be a group to help plan topics and identify speakers and then facilitate these meetings. If that's something you'd be interested in helping with, please email the df-coordinators@carc.org. That will get it to both me and Amy. And then an announcement about some scheduling. For August, we're going to do another kind of plenary with all the tricks. And this one's going to be around aspects of security. Plan isn't fleshed out yet exactly what that'll be, but like I plan to make sure there's a section on kind of data security, which is more around privacy than anything else. Should be an interesting plenary once we're done figuring it out. We don't know what time that will be yet. We're still also trying to work that out. But we will not have a regular data facing during our regular time for August. It'll be this plenary. Cool. And with that, let's get on to today's topic. Digital preservation and access at scale, how to manage the HathiTrust digital library, which is over a petabyte of data. And our presenter today is Aaron Elkes from HathiTrust. He's the enterprise architect for HathiTrust. Since 2010, Aaron has had a leading role in a variety of projects and issues around data management and digital preservation for HathiTrust. All right, so now I'm going to turn it over to Aaron.
All right, thank you. I'll share the presentation here. Looks like we should be set here. Thanks for the introduction. As Deb said, my current role is enterprise architect, which has kind of broad role around managing technology for HathiTrust. But since about 2010, I've been heavily involved in the repository and data ingest and systems aspect of HathiTrust. So I have fairly long experience working on and solving some of the issues I'm going to talk about today. So outline of what we're going to talk about. I'm going to give a brief overview of what HathiTrust is and some of the services we provide. I'll talk about how we store the data and then talk in more detail about how data and metadata gets into HathiTrust. I'll talk some about what we do to steward that data over the long term and finish up with several challenges and unmet needs we face around data management. So HathiTrust is a not-for-profit collaborative originally founded in 2008 by some of the original Google Books library partners, University of Michigan, the other members of the Big Ten Academic Alliance, and the University of California. We have since grown to comprise about 250 academic and research library members or partners from now 7 countries. We hold about 17.5 million volumes digitized from libraries, and we steward and preserve the collection under the aims of scholarly, not corporate interests. One of the major motivating factors was to provide something run by, built by libraries for faculty and campus researchers and students, rather than necessarily only the aims of Google Books. So I'm going to be talking a lot about volumes in this presentation, so I should define a bit what that is. A volume essentially corresponds to a particular thing that's on a library shelf. In the simplest case, that's just a normal book, but in more complex cases, that could be kind of one part of a multi-volume work, or it could be multiple issues of a journal or other serial. And there's a number of ways that we'll see over this presentation where having that connection to the physical item both makes it possible for us to operate at scale, but also poses a lot of challenges. So a quick overview of some of our services that we provide. We provide online reading access for everyone to up to about 7 million public domain and open access volumes. That's in the US. Worldwide, we can only provide access to about 5 million volumes because there are generally more restrictive copyright rules outside the US for items published prior to 1926 currently. As probably many of you are aware, we provide the emergency temporary access service during the pandemic, which makes it possible for member library patrons to obtain lawful access to specific digital materials in HathiTrust that correspond to physical books held by their own library. That service helped and continues to help many HathiTrust member libraries to support the teaching, learning, and research mission of their institutions while services are interrupted during the pandemic, or increasingly other disasters as well, and certainly something we plan to provide during any future disasters, especially as climate change causes more wildfires and disruptions in California. University of Cape Town in South Africa is not a member, but recently they had a fire, and we're looking at how to provide this service for them as well. American University in Beirut is one of our overseas member, and of course with the trouble there, their services were disrupted as well for reasons beyond just the pandemic. We provide full text search to all 17.5 million volumes that we hold, as well as catalog metadata search. And perhaps most of interest to this group, we provide computational text mining across that entire corpus via the HathiTrust Research Center. We also have a number of programs that help support our services. We have a shared print program, which develops a distributed shared network of print collections with collective print retention, with the goal of making sure that there are sufficient numbers of print copies held in member libraries of volumes, works that we hold in HathiTrust. We have a US federal documents program, which expands access to and preservation of US federal publications, which are always a great area for us to work in because US federal publications are for the most part public domain. And we also have a copyright review program, which finds and opens public domain materials in the US and around the world, although, as I'll talk about later, primarily really exclusively for English language material at the current time. So storage, how do we store 17.5 million volumes over a petabyte of data? Well, for each volume, we've got a zip file, which holds the page scans and optical character recognition, OCR derived text. And then we also have kind of a sidecar metadata file that holds descriptive, technical, and structural metadata using the METS metadata standard. Where do we store all that? We've got a primary data center in Ann Arbor. From there, we have a replica data center in Indianapolis. Both those data centers are fully active at all times and serve users worldwide. We also then have kind of 3 backup copies. 2 are using the Data Den tape archive at the University of Michigan, which is a research data tape archive. And then we also store a copy for disaster recovery to Amazon Glacier Deep Archive to have some kind of offsite and geographical redundancy. So with this, we have essentially 5 logical copies, the 2 online data centers, the 2 data den tape archives, and the Amazon Glacier. They all have their own internal storage redundancy, and that enables us to achieve a fair amount of storage diversity. We've got 3 different storage vendors, but since both our primary and replica data center use the same storage vendor, we have both spinning disk and tape media, and we have 3 different storage geographic locations. Most of it's in Ann Arbor, but then also our replica in Indianapolis and our replica in one AWS region in the cloud. So next, we're going to spend a fair amount of time talking about how material gets into the repository. We actually have 2 separate workflows for that, one for metadata and one for content. The reason for that is because usually the organization creating the metadata is the library, but in most cases, the organization doing digitization is Google or Internet Archive. And we do have some contributors who send us material directly, but the vast majority is about 95% is from Google, and most of the rest is from Internet Archive. Having separate workflows is in part so that the library can manage metadata separately from Google or Internet Archive, and in part because it allows us to have a little bit more control over the metadata we receive and to meet our specific needs. So the metadata that we receive is in the MARC bibliographic metadata format, which if you're not familiar with that, it's a standard that was originally developed in the 1960s as a sort of computer manageable card catalog format. By modern standards, it really has a lot of drawbacks and challenges, especially around lack of standardization about how various data fields like names and dates are formatted. But it's still the standard for library metadata, and because almost everything we have is scanned digitized books, that's the standard that we use. There's a system that's kind of allied with the digital library, which is run by California Digital Library. It's called the Zephyr Metadata Management System. And the way the metadata workflow works is that the contributor, like Michigan or Harvard or Cornell or whoever the book came from, will send metadata to Zephyr. Then Zephyr will do some processing and generate various reports and extracts that we'll talk about a little more later and deliver that to HathiTrust. We match up metadata and content via identifiers. Sometimes those are library barcodes that correspond to a barcode label that's on the physical item. There's also a fair amount of material that uses ARC IDs, which is a kind of stable, persistent identifier, similar to the DOIs, but kind of a separate process managed by individual institutions rather than by, it's a little bit more decentralized than DOI. And we generally prefer identifiers that are stable. They're not going to change over time, that the libraries can maintain connections to the metadata and the content, that are opaque, that don't really have any additional information or assumptions embedded into them that might change over time or be used in ways that would not be really appropriate, and that are relatable to the original item. Like with the library barcode, that's a physical thing that's stuck on the original item that's scanned. The relationship with ArcIDs is a little bit more indirect, but we can still kind of go back to either Google Books or Internet Archive or the library and see, where did we get this item up from, and relate it back to an original item on a shelf somewhere. So we look at the metadata that's got identifiers in it, and we try to match that up to content that we can get from digitizers, either, again, returned directly from Google Books or from Internet Archive, or in some cases directly from a contributor, just kind of uploaded via Box or Dropbox, as we're migrating to now. And it's really an ongoing process. It's not just a one-time thing. One of the ways that we can manage this in bulk is that a partner might send metadata for everything they think Google might eventually scan to Zephyr, and then over time we look and say, well, what can we actually ingest at any given time? Once we've got the content, we do some validation and normalization. We ensure that the book package we got is complete, that it has everything the contributor thinks it does, that at least from what we can determine from the file naming structure, that it appears complete. We ensure that the OCR text is at least valid UTF-8, and we have some image requirements around format and resolution and so on. We also add some kind of common image headers to images if they're missing them, in part so that we can, again, if an image gets disconnected from the package, that we can trace it back to where it came from, and also have a sense of who digitized it and when. Our ingest process is a highly automated and controlled process. We really strictly maintain the notion that only one process has permission to write into the repository, that anything else kind of needs to go through it, and there's kind of a strong separation of those concerns, that there's no ability to make any kind of ad hoc changes or corrections, that everything kind of needs to be corrected upstream and then go through the reingest process. And we'll talk later about some of the challenges with that. But once it's been validated and normalized, it gets deposited on spinning disk in our primary data center. At the same time, it will also kind of synchronously make a copy to both DataDen and Glacier and wait for that to complete before it says, yes, this is actually ingested. We kind of keep a manifest of everything that we think is in the primary data center, as well as in the backup systems in a relational database. And then the replicas, both of DataDen and our replica data center, are handled kind of automatically by the storage systems themselves, at least for the time being. Worth mentioning that the replicas to DataDen and Glacier are new as of this year. Prior to this, we were backing up at the file system level to a backup system called IBM TSM, which posed some challenges in that it was harder to kind of get an inventory or manifest of what was there. So we're, I think, doing a better job of managing our backups now that we're doing it as a more active process at ingest time rather than passively as part of the system backup process. So back to the metadata side, once we've got the content in, we let the digital library let Zephyr know that items were ingested, that they're available. There's this notion of clusters of items. Typically that's at the title level. So we might have kind of multiple copies of a single work. Those would all be in the same cluster or catalog record. Likewise, if we have kind of multiple issues of a journal or other serial, those would all go in the same cluster. And that's currently based on the OCLC control number submitted in the record by the contributor. If you're not familiar with the OCLC control number, or OCN, that's a bibliographic identifier used in a system called OCLC WorldCat, which is a database of holdings of thousands of libraries across the world, and is kind of an attempt to come up with a common title level identifier for a particular work. It's not always perfect, but it's the best that we've been able to come up with so far without applying a lot of machine learning approaches, which we're definitely interested in doing in the future. But for now, we primarily rely on this OCLC number. When partners submit metadata for items, they submit kind of a metadata record for each item. So that means, say, if Michigan and Cornell both digitized, say, the birds of North America or something, they would submit separate metadata for that to Zephyr, but we would be able to figure out, ideally, by the OCLC number, that those were the same thing. And then one of the primary functions of Zephyr is to try to pick one record to represent that item. It's got a notion of kind of the best or preferred record based on the presence or completeness of various metadata fields. But that can be problematic because the algorithm is a little bit opaque. There's kind of particular biases and points of view that are embedded in the record selection that could mean that useful information gets lost. That's another challenge we'll talk a little bit more about later on. And then once Zephyr has kind of picked a preferred record and grouped things into clusters, on the digital library side, we create a catalog index based on the preferred record for each item. We also do the full text indexing after items are ingested. A really important thing in the digital library is rights determination. Like I mentioned, a lot of the material is public domain. We can make it available to everyone, but not everything is. There are a lot of challenges to doing this automatically, not the least, which is that the MARC metadata format does not always make it easy even to determine like the date of publication for an item. For example, sometimes if the date of publication is not known, but it's known to be in the 20th century, the cataloger might enter just 1900 as the date. And so you don't know, does that really mean the date is 1900, or does it mean sometime in the 20th century? And that can really throw things off. And it's, in part based around the idea that MARC was not really intended for these kinds of uses, that it was really intended more as a digital card catalog than as something we can really operate on algorithmically. But we do try to extract the date of publication, the country of publication, and whether or not it's a US government publication as best we can. That gets us a lot of the way. And then we also have a number of processes that can override those automatic determinations. If contributors apply a Creative Commons license to their work, we can make it open for everyone. We also have a manual copyright review process that gets at a lot of the peculiarities and holes between copyright law and the information we have in the bibliographic record. So we have a team of experts from all our many of our partner institutions who volunteer part of their time to review these things. And finally, if a rights holder contacts us and lets us know they don't wish their work to be in HathiTrust, then we can restrict access. There's a link in the presentation to some more detail about how we do this if you're interested. So for full text indexing, we do index the full text, including in copyright material that we can't generally make viewable. And we also provide the ability to search within a book. which lets us search at the page level. There were, when we originally implemented full text indexing, there were a number of challenges related to trying to do page level search and kind of snippet view. One is just the technical question of how we do that for billions and billions of pages, but also a policy question at the time anyway about showing snippets of in copyright material in search results. So our full text index, we use Solr for this. It's about 12 terabytes. And we've optimized it a little bit differently from how a lot of search things operate. We've really optimized it to try to handle a large amount of data at somewhat reasonable cost rather than trying to deliver results as fast as possible. We've been in the process for a while of looking at moving that index from we have kind of 6 bare metal servers at each data center currently. We're looking at moving that into AWS, which will give us more options in terms of how we structure the index and how we scale the index, and more ability to experiment with how we do full text search going forwards. Finally, once everything is ingested and indexed, we can provide it to the HathiTrust Research Center. We provide the full metadata and OCR text of all materials to the Research Center. We can also provide public domain subsets of material to individual researchers upon request. The Research Center provides an analytics portal for running kind of canned algorithms against the entire corpus or kind of whatever subset you might be interested in. And the Research Center also offers data capsules, which are virtual machines with some protections against exporting material without human review. And those let researchers run kind of more custom algorithms against all material, including in copyright material. There's kind of increasing interest in using the images for computational research as well, which we've done some at a small scale, but because we have, almost a petabyte of data, that's so far been challenging to figure out how to do that routinely at a large scale. Although we've had some thoughts around attaching more compute directly to our storage at one of the data centers, or about making that storage directly accessible to some of the high performance computing at either Indiana or Michigan. But so far we haven't gotten too far with that. How do we preserve this material long term? So we have a few auditing processes that we run. One, as I mentioned, there's kind of internal mechanisms for each kind of storage. We also do weekly inventory checks for just making sure that our relational database and looking through the inventory of what the storage system thinks it has match. We also do at our replica data center a full read and checksum comparison every 3 to 4 months. And with Datadata and Glacier, we also do kind of a daily test restore of a small handful of items. Prior to migrating to Datadata and Glacier, we weren't really doing the regular test restores or inventory audits, so that migration has really been a chance to improve our management of backups. From time to time, we need to do storage migrations, like the backup storage migration that I mentioned, or a metadata format migration. That really uses the same process as Ingest, where we track and manage and control access to that pretty closely. There's kind of a queue of items to process, and we log the results of that and track success and failure. We've used that both for the backup migration that we've been working through, as well as in particular migrating from version 1 of premise metadata to version 2, which is mentioned premise a little more later, but it's a metadata schema for tracking preservation actions that have happened to material over time. Actually, right now, premise is, we use premise XML. There's a newer version that uses RDF or linked data that we haven't yet migrated to. But essentially what we track with that is each time the item is scanned or ingested or migrated in some way. And that gives us just a record of what's happened to the item at a high level. Some people use Premise to track events at a more granular level, but we don't do that. For example, we don't track each time a storage audit happens or every time we kind of provide access to the item. That would be too much to store and manage. So I'll move on to talk about challenges and unmet needs. But before that, I do see one question. Do we have a specific tool for backing up to Glacier Deep Archive? No, not really. We use just AWS CLI and have called that from our ingest tools to upload to it. But then we've got some kind of additional tooling around of tracking what items are there without needing to use the AWS inventory itself, and making sure those are in sync is what the auditing stuff is about. But we also don't really have a process for if we needed to manage a bulk restore from Glacier Deep Archive. We haven't really thought through how we would manage that at scale. We're still wrapping up the initial migration there. We have a better sense of how we would do kind of a bulk restore from our data den tape archive on campus. So I think thinking about management and tooling around Glacier Deep Archive and improving that is future work. I see a couple more questions. So during the pandemic, HathiTrust made many more resources openly available. What were the usage stats with the more open access? It's a little bit hard to tell because we really started tracking usage more granularly like right after the pandemic started and after we started using ETOS. But we did see kind of at the peak around the end of winter 2020, usage was quite heavy and up by well over 50%, up by as much as double pre-pandemic usage on some days. But ETOS, the Emergency Temporary Access Service, contributed to that. But I think just in general, people became more aware of HathiTrust in general and using it to find all kinds of resources, not just in copyright material. So let's see, how much of the data is usually computed on through the data capsule? I'd have to defer that question to my colleagues at the research center for the most part, but my sense is that it's typically a relatively small amount, like in the thousands to tens of thousand volumes, rather than trying to operate on the entire corpus. That usually people have kind of a specific research question they're trying to answer based around a set of volumes that they select rather than the entire corpus. The compute for the research center takes advantage of the high performance computing at Indiana University. But all the stuff that I'm talking about today in terms of the repository itself is in data centers in both Ann Arbor and in Indianapolis. And Globus endpoint, no, we don't. That's something I think worth talking to the research center about. I think part of the reason I have a little bit of familiarity with Globus, but not a huge amount. My sense is that one of the reasons we have not done that yet is because it is kind of challenging to manage the data for individual volumes. And there's kind of an approval process to get access to even the public domain material. But often researchers will kind of want a specific subset of data, and so it might be kind of tens of thousands of small volumes to transfer rather than kind of a single large data set. And my sense at having looked at Globus a little bit is that that doesn't work that well for Globus needs, or for the way Globus works, but you know, it might be something we look at in the future. All right, so going on, we'll talk.
Real quick,
Sorry.
follow-up. My question about how much of the data is computed on, I was kind of more getting at like, probably a significant amount of the storage is the scanned images, right? Which
Yeah.
traditionally hasn't been computed on. That's what you're
Right.
working on right now?
Yeah, that's correct. I wouldn't say we're necessarily working on that so much as there's interest in doing it, and we've done it at a small scale, but we don't really have plans for providing compute across the entire data set. So my sense is that the full text is around 12 terabytes. It might be a little bit more at this point. Yep. All right, any other follow-ups or clarifications on those questions before we go on to the challenges? All right. So challenges and unmet needs. We have a fair number of them. One is that our workflows are pretty complex and idiosyncratic in many cases and have evolved over time. It's challenging for us to manage changes to digitized volumes over time. As I've alluded, there's a lot of challenges with working only with MARC metadata. And we have a lot of challenges in working with non-English and especially non-Latin script data, both for metadata and content. So our workflows. A lot of the stuff I've described with both metadata and ingest is a collection of really not very consistent processes that have evolved over time. There's a lot of kind of nightly processes that work on manifests of items in various idiosyncratic text-based formats. We don't always have great documentation of those formats or the processes. They don't always work in consistent ways. So one of the things that I have tried to work on over time, although I think the pandemic has delayed this, is working towards a more event-driven architecture with a central message broker. Right now on the right, this is kind of an overview of all the different processes that are moving metadata and data around. And each one of those lines and arrows is its own separate process with its own separate timing and rules and data formats. And the goal is that all those processes have a reason to exist, but we want them to operate in a more consistent way and to be more understandable and consistent in how they operate. Another major challenge from a data perspective is handling changes over time. So over time, depositors or digitizers can correct errors in items or otherwise improve items. That might be to replace missing pages or to fix illegible scans. There's one example of something going badly wrong. They're called warp, with a kind of a scan artifact from the Google Book scanning process. We also would like to improve OCR over time. The OCR engines that were available when items were digitized, we expect will improve over time, and we'd like to refresh that over time. And there might be other kinds of quality problems or other things we might want to change. Um, but it's challenging for a couple of reasons. One, because right now fixing any problems in the book really has to go through the digitizer, either Google Books or Internet Archive, or the library who provided it directly. And that's because in our model right now, if changes were say, we had a volume that the OCR wasn't very good, and a patron said, I've got better OCR of this volume, or I manually corrected it and I'd like to provide it to you. Like, we could put it in HathiTrust, but then, what happens when something changes upstream with that volume at Google Books? Now changes have been made on both ends, and you really don't have a model for reconciling those changes. That model also kind of reveals a number of assumptions about how we think about digital items. Um, Really, that we're kind of assuming that the digital item is only valuable as a surrogate for the physical item. If we get a new version of an item, we can't kind of keep all the previous copies of the item, or we made the decision not to, in part because it has kind of been decided that that would have too high of a cost to benefit ratio. And it's kind of the assumption that newer versions of an item are going to monotonically improve over time, that if we get a new version, it's always going to be better than an old version. And those assumptions may or may not be true. I think we have some evidence that a new version doesn't always improve something, and we don't always have a good way of finding that out. But it certainly creates a number of challenges, especially when thinking about using the items as data. Um, so one, it's very, very difficult to know really what has changed between digital versions. Like, when we get a new scan from Google, if we're just kind of looking at image checksums, even if the underlying images are the same, um, the the image files themselves will have changed. So without kind of running computer vision tools and trying to do alignment, which would be pretty expensive computationally, it's very hard to know what might have changed. And of course, it also causes problems for replicability of text mining results. If you're running on a data set that has OCR that was created at a particular time, and then that OCR is later refreshed or updated, the OCR might be better, but you're certainly going to run the risk of getting different results from your experiment unless you've kind of archived the particular version that you were working on at any particular time. And finally, even just for kind of general researcher use, not necessarily in thinking about it as data, it's difficult because, say we've inserted a missing page. Now the link to that page will have a different URL. And so if you've linked to a specific page, that might not be stable across time. That we might be able to do something about in a couple of ways, but in general, it's can be a difficult problem, again, because we don't have a good way of knowing exactly what might have changed between versions. Metadata is another big challenge. So, like, as I mentioned, Zephyr is really, our metadata management system is really organized around MARC. It's very organized around the presence of specific MARC fields to determine of what belongs together. And this notion of MARC is also really oriented around the notion of the digital as a surrogate for the physical item rather than its own thing. In library land, there's this notion of electronic records for an item where an electronic version is kind of cataloged as its own thing, but the records we have use the records for the print version of the item, and so we're we're really making the assertion that what we have is kind of a version of the print item rather than its own thing. There's also a lot of interest in being able to use linked data and in incorporating other kinds of data from outside, for a number of reasons. One, kind of potential improvements to discovery systems, like being able to encode the relationship between multiple versions of the same work in a more explicit way, doing a better job of automated copyright determinations potentially, and in integrating outputs from machine learning or from other data sets, like the HathiTrust Research Center extracted features data set, which kind of runs a number of machine learning models and extracts things like named entities and geographic places and so on. Likewise, the requirement for MARC metadata really limits the kinds of material that we can accept. Even if we're thinking about other textual formats like EPUB or PDF, those don't always have MARC metadata, or maybe not very complete MARC metadata. And that's a challenge for us for accepting that kind of material. We also rely on contributors to update metadata, and there's a lot of variation in terms of the resources that partners have to correct metadata. So overall, the processes that we have are really designed around the needs of digitized book materials coming from libraries, and that kind of gives us a sense of why we can work at scale with digitized book material, because we've made these assumptions about what we're going to get and how we're going to manage it, but it's also something that hinders change. We do have a community metadata strategy task force that's working on a lot of these issues, especially around kind of the corrections process and some of the issues around kind of record selection that I mentioned earlier with Zephyr. And finally, I want to talk about a number of challenges we have with language. All of but two of our partners are in predominantly English-speaking countries. We have two elsewhere: American University of Beirut in Lebanon, and the Universidad Complutense de Madrid, which is the only European Google Books partner to join HathiTrust. And it's kind of a problem that reinforces itself, because most of our partners and most of our expertise is English language. That's what tends to get focused on, and so the lack of support begets continued lack of support. We have very limited expertise for copyright review for material that was not originally published in English. We also have a hard time doing user support or member support in non-English languages. Our interface only supports English at the current time. We don't really have any help text in other languages. But only 51% of our collection is in English. There's over 500,000 titles in Chinese, Japanese, Korean, over 150,000 titles in South Asian scripts. Only about a third of that is Hindi, and there's a number of other South Asian languages which have kind of even worse support than Hindi in the OCR and discovery pipeline, and over 150,000 titles in Arabic script. And our support, especially as far as full text search and metadata goes for that, is not very good. We do have some support for right to left reading, which can certainly help with Arabic and Hebrew and some East Asian material as well, but on the whole, our support for that is not very good. And increasingly, HathiTrust has been trying to focus on equity from a number of perspectives, and recognizing some serious gaps in our membership, in our collection, and the the way the collection was acquired, and the services we offer, and in our metadata. And in a lot of ways, language is really central to all of those. So just to kind of sum up with our challenges, I think a lot of assumptions that we made around metadata and how we're getting material and around language that helped us to work at scale early on, but they really challenge us now in expanding. We did a lot based on of what was feasible at the time when we were implementing things, but in order to meet user needs now, we really need to revisit those assumptions and engage in more conscious design work about the services we're offering and how we deal with our data. That's about it. Thanks for listening. There's a lot more information about our specifications and workflows and data management at the URL in the presentation. And I think we have a few minutes for more questions or discussions on the challenges section or anything else I mentioned earlier.
So I don't see any more questions in the chat or in our document, but if somebody wanted to just unmute and ask a question, feel free to do that.
I've got another one if no one else has one. Do you run into latency problems with all this data flying around?
Yeah, so one of the challenges I mentioned is really how everything is working kind of in a batch manner right now. So essentially what happens is we have a lot of processes that run kind of on a nightly basis, like the Zephyr's metadata export, and then our ingest, and then replicating that and getting it to our other data centers, and then to backup, and then doing full text indexing. And so from the time a contributor has digitized an item and submitted metadata, it can take kind of up to a week before that's fully available and discoverable. So yeah, that's a big challenge, and something it's something that it's come up kind of more with certain collections than others. I think for the kind of bulk material digitized by Google, it hasn't been kind of as big an issue. It's kind of, well, you know, they'll digitize it and we'll get it when we get it. I think especially during ETOS, when partners might have been submitting digitized material directly to us to support a course, it can be a bigger challenge and more frustration, and we really have to think through all those timing issues to make sure that people can get access when they need it. You know, kind of another big challenge around that has been keeping the data set at the research center in sync with the main repository. One of the things that they are working on, and there's kind of a new grant around this, is about, in part, keeping that extracted features data set up to date with what's in the repository, and kind of having a dashboard and API access rather than just kind of a static snapshot. And that's kind of really a precondition to being able to use that kind of data and integrate it more in the discovery and access layer. Any other last questions? All right, well, I think that wraps it up, and I'll hand it back to you, Deb, to wrap up.
Cool. Well, that's about it for this month. Reminder, or if you weren't here at the beginning, August is going to be a plenary session. It may be at the data facing slot, but if it is not, we will not be having a specific data call. So more info on that to come soon. And that's about it. Thank you all for coming.
All right, thank you.
Thank you.
Thank you, Aaron.
Thank you.